The little wires with the controls, the protection, the communication, the computer systems. And these are the ones that cost about 80% of the gray hairs and ulcers on the control system. This is the rotor, one of the originals. You can see it's pretty big. This is 32 feet in diameter and weighs about 400 tons. It spins at 120 RPM. Now this is the stator, or stationary part, also called the armature. And what the rotor is just a large magnet. As it turns, the magnetic field spins around, cuts through the copper windings of the coils here, and that's how the electricity is generated, and how energy is transferred from the rotating mass, mechanical, into the electrical system.
This is the scroll case. The rotor sets up here, the runner sets down in here, the water comes in, hits these stay vanes, and throws it in the impeller, and then that in turn is what rotates your generator. But they must not have had OSHA in Sweden, because you don't see any hard hats, and the bottom of that ladder doesn't have rubber feet on it.
That black hole is the penstock bringing water down from above. And that's 20 feet in diameter. It's getting smaller and smaller because some of the water is going into the machine all the way around as we go.
The wicket gates set down in these holes. These wicket gates are controlled by a governor, and they'll open and close, and that controls the amount of water going through to maintain your 120 RPMs.
The normal flow here is 8,800 cubic feet per second for each machine. This is the end of the scroll case. As you can see, it's coming down to almost nothing here. And the water, as I said, goes radially inward into the turbine. And then down through a much, much larger hole and then out to the river.
It was brand new, state-of-the-art, cutting edge. You know what that means.
They were spilling out of the spillways up above here and spilling from the sluice gates here. So this whole area of the downstream side of the dam was just a constant cloud of spray and water vapor. Bearing in mind this is now December, January kind of time, was that this whole downstream side of the dam was just like a giant popsicle. And the ladders, where you couldn't walk the ladder, climb the ladders or walk on the causeways, you couldn't get around. And in addition, up above here, the gate hoists, or the sluice gate hoists, were out in the open. Now that goes back to the fact that the designers of the project were California engineers. I hate to knock the California engineers, but this is semi-Arctic up here in the wintertime. And those hoists were so covered with ice from all of the spray and so on that some of the construction people who were still on board here were up there with fire axes to chop the ice away so that the gate hoists could be kept operational. That being an example. So we had hoists up above the intake, hoists here in trouble. There had been some wheel problems with these sluice gates as I remember them. We had a turbine out, we had a generator in trouble, And there was a lot of other minor stuff.
A lot of the systems, because of the time frame in the mid '60s, were developing technologies. I call them Mona Lisas. They're kind of like one of a kind.
The rock is really so very vital here, not just the support of the dam, but the rock as a vehicle for enclosing everything. Everything, practically speaking, that moves, makes noise, and generates electricity is in the rock. It's in tunnels, in the underground powerhouse. Well, I happen to have been functioning temporarily as an operator over here, and I was all by myself in the powerhouse. It was at night, and suddenly there is this tremendous thump, and two of the four machines are knocked off the line.
Yeah, he told me, he said it was a big bump. I said, well, what kind of a bump? And he said, it's a bump.
I said, the kind of thud you feel up through the bottom of your feet. What had happened was the intake gate had broken loose from the link supporting it. It had slid down the chute without any of the braking system that we had so carefully prepared. Hit the sill, and that's what the jolt was. Scared the living daylights out of me, I don't mind saying.
I can talk to you as soon as I wipe up the floor.
When you're alone here, all by yourself, and nobody else around, and the control room, as I remember, is below lake level, one cannot help but wonder at times about the escape route. And in the private moments, operators have talked to me and mentioned the fact that one guy thinks his best way out is through this portal, and another guy out the other. I think that all of the operators at Boundary that I've talked to have had that same concern about being trapped in the underground powerhouse. You have that uneasy feeling that if something goes wrong and the water starts to rise, where do you go? I don't know, I think I would have just gone as high as possible and maybe even gone to the catwalk above the powerhouse. There's a catwalk up above the ceiling of the powerhouse, which is very spooky, I might know. In fact, the night of the big thump, it was enough of a thump that I walked up there myself and went the full length of the powerhouse above the ceiling just to make sure there wasn't something leaking or whatever, you know. If I'd have been a civil engineer, I probably wouldn't have worried about it. But anyway.
They had a crane set up here, and it toppled into that channel, and I think that crane is still down there.
Well, it fell in or something.
Yeah, it's filling upstream.
Now, where is it? It's up by the dam, or is
No,
it?
right there. You see where that has been?
It's not entombed in the concrete. It's down.
Part of it is. Starts up the river. It had a couple of
Massive landscaping makeover. University of Washington students were key to making this happen.
The Public Art Program is a brand new interdisciplinary program funded by a University Tools for Transformation grant. And what it is it represents the fusion of 4 different disciplines: art, industrial design, landscape architecture, and architecture.
They call it a design-build process where students in these different fields design the improvements and then build them. It's a win-win. The community gets incredible improvements and students get a great portfolio with real-world examples of their design work. About 35 students put in thousands of volunteer hours alongside neighbors to make this all a reality.
For $60,000, we're getting probably $500,000 worth of improvements here. If you figure in all the design time that the university students put into it, the volunteer labor that they've put into it, and all the community volunteers.
The improvements are many, from an entryway resembling an arbor, to public art, to 2 working cisterns resembling art that collect and hold rainwater from the roof for the expanded pea patch. Since Seattle is a rainy city, the inevitable overflow from these holding tanks is also made to look beautiful, becoming an urban waterfall and stream for the community center.
The pea patch is enlarged. This is a very, very popular pea patch, and as you know, pea patch has a waiting list of people who want to get involved. With the increased space here, I think we're going to have room for at least, 15 more farmers? You can see there's a lovely new fence, there are birdhouses, there's art, there's a central plaza.
Incredible upgrades for the most heavily used community space in the neighborhood that is also the site of Seattle's largest farmers market. Next to the University Heights Center is University Way, or the Ave as it's commonly called. This retail core for the University District has fallen into disrepair over the years. Prime stores have moved out, and it's been an increasing concern to the community.
People often break their ankle walking down the sidewalks, and they can't talk to a friend because the sidewalk is so narrow that they might, run into a parking meter, run into a sandwich board. It wasn't attractive. The lighting is terrible at night.
But changes have begun. Big changes are reshaping the entire character of the Ave.
The sidewalks will be widened 2 feet on both sides. New lighting, new infrastructure of water mains and electricity, trees, street furniture, design elements that tie the Ave into the campus architecture.
A big art project will also wind its way down the Ave, but none of it would have been possible without a Neighborhood Matching Fund grant.
Certainly the personnel from the Department of Neighborhoods have been key actors in putting this all together, smoothing our way with the City Council and the Mayor and with all the city departments. And no, we could not have done this without their assistance.
Community volunteers also took the time to recognize the most architecturally significant buildings in the U District. Through a program called the GEMS Project, neighbors surveyed 2,000 buildings, then boiled the list down to 100 structures they plan to seek landmark status for.
This is an initiative that Peter Steinbrook spearheaded through the City Council to arrange with Historic Preservation for grants to be available and for funds to be available to neighborhoods to do these kinds of historic surveys.
Back in Lake City, pedestrians are seeing some sidewalk improvements.
Lake City, is noted for almost anything outside of the commercial core for the lack of sidewalks, and that is probably the #1 issue in the neighborhood.
Lake City Way is being improved for pedestrians, and the city is expanding out from there, laying sidewalks like this one just a block away. In fact, another new sidewalk the city laid is being touted for its environmental benefits, according to Cheryl Klinker.
It's fish friendly because it was specifically constructed to minimize or reduce the amount of runoff coming off of the impervious surfaces and into the storm drain system.
The sidewalk is a 9-foot wide green belt filled with native plants, catching much of the runoff and returning it to the soil. Neighbors like the pedestrian safety the new sidewalks provide and the respectability the developments bring to Lake City neighborhoods that have felt neglected in the past. Our final stop is also in Lake City, where neighbors are using volunteer sweat to turn a neighborhood service center into a busy food bank every Friday and Saturday. What serves as an office Monday through Thursday gets converted by these volunteers into a small food warehouse at the crack of dawn Friday morning. According to Executive Director Rita Anderson, the Department of Neighborhoods actually suggested using the service center as a part-time food bank when a nearby food bank closed down.
It's centrally located, it's on a bus line, it's in the middle of low-income housing area. You know, this area in 9125 zip code has, what, almost 6% of all the low-income housing in the city of Seattle.
In other words, this is one heavily used food bank, and unfortunately, the need keeps growing all the time.
Every Saturday, we have 200 to 250 families go through here.
So there's a fantastic need for
Oh, there's an incredible need. We have over 20 families that sign up, additional families, new families, every week that sign up every Saturday.
At the Lake City Neighborhood Service Center, Neighbor truly helps neighbor, 6 days a week, and especially on Fridays and Saturdays. These projects in Seattle's urban neighborhoods are only some of the hundreds of projects the city and neighborhood groups are completing across Seattle as a result of neighborhood planning. It's the marriage of local ideas, volunteer labor, and sweat, commingled with the resources of city staff, neighborhood matching funds, and private donations from businesses and foundations. It's all making Seattle and every one of its neighborhoods that much better.